In this video, we're going to take a quick look at polymers. So we'll cover their structure and bonding, how to draw them, and why they're solid at room temperature. Now, polymers are a huge and diverse group of different substances, and they make up all sorts of things. What they all have in common, though, is that each polymer molecule is made up of lots of smaller units called monomers. For example, polypropylene is one of the main polymers in plastic, and a single molecule can be thousands of atoms long. But it's actually made from these monomers, called propene, which have the formula C3H6. And if we line a few of them up, you can see how they could keep adding together again and again until they form a huge polymer chain. Now, the important thing to be able to do is notice that a particular molecule could be a polymer, and identify the repeating monomer. For example, we can tell that this polypropylene we just made could be a polymer because we can pick out a small section that seems to repeat. Then, once we've identified this repeating unit, we can draw it out by itself. And you'll often see the letter N in the bottom right corner, which represents how many of those repeating units there are in the overall polymer. So if we wanted to write a reaction for combining 400 propene monomers, then instead of drawing out the entire polymer as a product, which would take us ages, we could just draw the repeating unit and put 400 in the corner. In general though, we just put N instead of actual numbers. The other thing to notice with these repeating units is that we always use curved brackets, and we show the bonds coming through the brackets. Now, the last thing we need to look at is the melting and boiling points of polymers. The bonds within the polymers are all covalent bonds, which are really strong, and so would require really high temperatures to break. However, to melt or boil polymers, it's not actually these covalent bonds that we need to break. Instead, it's the intermolecular forces between the separate polymer molecules. And these intermolecular forces are much weaker than covalent or ionic bonds. However, because the polymers are so long, they have a high surface area, and so there are loads of these intermolecular forces, which means that to break them all would still require quite a lot of energy. So, although polymers have lower melting and boiling points than giant covalent structures like diamond, or giant ionic structures like sodium chloride, they do have higher melting and boiling points than simple molecular substances, like oxygen or chlorine, which only have a few of these weak intermolecular forces between each molecule. And this is the reason why polymers are generally solid at room temperature. As we said earlier, there are loads of different types of polymers, and two of the main ones are addition polymers and condensation polymers, which we'll take a look at in other videos. That's all for now though, so thanks for watching, and we'll see you next time.